summation of the I/L ratio of the columns divided by the summation of the I/L ratio of the beams. And in that case, since we have two columns, we're going to multiply this with 2, and I/L ratio for the column was 0.87 10 to the 6, which we have calculated here for the column. And the same for the beam. Since we have two beams, again we are multiplying it with 2, and the ratio of I/L for the beam was 0.52 10 to the 6. And when you do the computation, we get the alpha value as 1.7. So since we get the alpha value, we need to move on to calculate the k values and use the smaller of those to get the clear height of the column, and then to get the effective length, and at the end, of course, to check if we need to account for second order moments. Okay, let's move on. So, as you know, we have two different formulas for the k. So the first one is 0.7 plus 0.05 times alpha 1 plus alpha 2, and the second formula is 0.85 plus 0.05 times alpha 1. We use smaller of those equations, okay? So we know our alpha 1 is equal to alpha 2 and is equal to 1.7. So let's plug those into the equation we have provided above. So the k becomes 0.7 plus 0.05 times 1.7 plus 1.7, and the second one becomes 0.85 plus 0.05 times 1.7. So the answer to the first one is 0.87, and answer to the second one is 0.935. So since 0.87 is the smaller one, we are going to use that one in our calculations. So our k value now is 0.87, okay? Let's move on to calculate the clear height of the column. And to find the clear height of the column, we need to subtract from the height of the column the beam depth. And the beam depth was given as, let's see, 500 millimeters in the question. The column length was 6 meters, so we're going to subtract this 500 millimeters, which is equal to 0.5 meters from 6 meters, and this will result in the net length. So L minus 0.5, which is 6 minus 0.5, and we are left with 5.5 meters. This 0.5 was the beam depth that was given in the question. So for getting the LK, we are going to multiply this ln value with the k value that we have found above. So our k value is 0.87 and our ln was 5.5, so I'm multiplying this with that. And when we do that, the answer is 4.8 meters. Let's find the ratio of LK to the I, because we will need this information to see if the second order moments can be neglected or not. So LK over I becomes, LK is 4.8 meters. I, we have calculated the I as 150 millimeters, so it is equal to 0.15 millimeters. And when we do the division, our answer is 32. Let's keep this in our hand and recall from our lecture notes when can we neglect the second order moments for a braced frame. So for a braced frame, second order moments can be neglected if the following condition is satisfied. And what is the following condition? It is LK over I less than 34 minus 12 times MD1 divided by MD2 less than or equal to 40. Let's calculate that. So it is 34 minus 12. And what is our MD1? Our MD1 is 200 and MD2 is 250 as it is given in the question at the beginning. So I'm just plugging in those values as they are. 200 and 250. Let me do the computation. So the answer is 24.4. So since the condition I wrote here is not satisfied, we need to calculate the second order moments. So second order moments need to be calculated, okay? We cannot neglect the second order moments in this question. So how do you account for the second order moments then? Well, I have provided